Good morning, ma'am. Good morning, classmates. So, this is module number 13, all about Assemble Language Program. Assemble Language Program. A program is a set of instruction or commands needed for performing a specific task by a programmable device such as a microprocessor. The program needs for a programmable device can be developed at three different levels. There are three parts. One is machine level programming, two assembly level programming, and three high level programming. In machine level programming, the instructions are written using binary code which use only two symbols, 0 and 1. The manufacturer of microprocessor will give a set of instructions for each microprocessor, and binary codes include a binary code will represent each operation performed by the microprocessor. The language in which the instructions are presented by binary codes is called machine language. A microprocessor can understand and execute the machine language program directly. The binary instruction of a microprocessor will not be the same as that of another microprocessor. Number 2, assembly level programming. In assembly level programming, the instructions are written using mnemonics. A mnemonics will have a few letters of English language which represent the operation performed by the instruction. For example, the mnemonic for the instruction which perform addition operation is add. Number 3, high-level programming. In high-level programming, the instruction will be the form of statements written using symbols, English words, and phrases. Each high-level language will have its own vocabulary of words, symbols, phrases, and sentence. In high-level programming, this is an example of high-level programming. Source file, then goes to assembler, and goes to object file. Came from source file, assembler, and object file. It will compress in linker. After it will compress in linker, it will go to executable file. Then the program binary will go to linker. That is a build up a program. Assembly language program development tools. There are 8 parts of assembly language program development tools. Assembly language program development tools. The development system is used by system designer to design and test the software and hardware of a microprocessor-based system before going for practical implementation or fabrication. The microprocessor development system consists of a set of hardware and software tools. The hardware of development system usually contains a standard PC or personal computer, printer, and an emulator. The software tools are also called program development tools, and they are editor, assembler, library builder, linker, debugger, and simulator. These software tools can be run on the PC in order to write, assemble, debug, modify, and test the assembly language program. This is part of assembly language program development tools. First, editor or text editor. The editor is a software tool which, when run on a PC, allows the user to type or enter and modify the assembly language program. The editor provides a set of commands for insertion, deleting, modification of letters, characters, statements, and etc. The main function of an editor is to help the user to construct the assembly language program in the right format. The program created using an editor is known as source program, and it is usually saved with file extension or ASM. 2. Assembler. The assembler is a software tool which, when run on a PC, converts the assembly language program to a machine language program. Several types of assemblers are available, and they are 1. Pass assembler, 2. Pass assembler, macro assembler, cross assembler, resident assembler, and meta assembler. In one pass assembler, the source code is proceed only once, and we can use only backward reference. In one pass assembler, as the source code is proceed, any labels encountered are given and address as short as address and stored in table. Some examples of assemblers are TAMS or Borland's Turbo Assembler, MAMS or MASM, Microsoft Macro Assembler, ASM86, Intel's 8086 Assembler, ASM85 or Intel's 8086 Assembler, etc. Advantage of assembler. 1. The assembler translates mnemonics into binary code with speed and accuracy, thus eliminating human errors in looking up the codes. 2. Assembler assign appropriate values to the variable used in a program. This feature offers flexibility in specifying jump location. 3. It is easily to insert or delete instructions in a program and reassemble the entire program quickly with new memory location and modified address for jump locations. This avoids rewriting the program manually. Number 4. The assembler checks syntax error such as wrong labels, opcodes, expression, and etc. and provide error message. However, it can check logic errors in a program. 5. The assembler can reserve memory locations for data or result. 6. The assembler provides list file for documentation. Those are 6 advantages of assembler. Next is library builder. Library builder. The library builder is used to create library files, which are collections of procedure of frequently used functions. Actually, a library file is a collection of assembled object files. While developing a software for a particular application, the programmer can link the library files in their programs. When the library file is linked with the program, only the procedure required by the program are copied from the library file and added to the program. 4. Linker. The linker is a software tool which is used to combine relocated object files of program modules and library functions into a single executable file. While developing a program for a particular application, it is much more efficient to develop the program in modules. The entire task of the program can be divided into smaller tasks, and produce for each task can be developed individually. These procedures are called program modules. For a certain task, we can use library files if they are available. Each module can be individually assembled, tested, and debugged. Then the object file program modules and the library files can be linked to get an executable file. 5. Debugger. The debugger is a software tool that allows the execution of a program in single step or breaking point mode under the control of the user. The process of locating and correcting the errors in a program using a debugger is known as debugging. These are the 7 parts of debugger functions, or the functions of debugger rather. 1. Debugger allows looking at the contents of registers and memory location. 2. Debugger allows to extend 8-byte register to 16-byte register with the help of extended register options. 3. Debugger allows setting breakpoints at any point with the program. 4. The debugger will run the program up to the instruction where the breakpoint is set and then stop execution of the program. At this point, we can examine registry and memory contents at that point. 5. View registers contents. 6. Trace the program step by step. 7. Execute the program completely at a time. That is the 7 functions of debugger. Simulator. Simulator is a program which can be run on the development system or personal computer or PC to simulate the operations of the newly designed system. Some of the operations that can be simulated are given below. These are the four operations that can be simulated. 1. Execute a program and display result. 2. Single step execution of a program. 3. Breakpoint execution of a program. 4. Display the contents of register or memory. 5. Loader. Loader is a program which assists absolute address the program. This address are generated by adding to all the offsets the address from where the program is loaded into the memory. Loader comes into action when you execute your program. This program is brought from the secondary memory, like disk or floppy diskette, into the main memory at a specific address. Let us assume the program was loaded at address 2000H, then 2000H is added to all the offset to get the absolute address. Once the program has been loaded, it is now ready to run. And the last is emulator. Emulator is a mixture of hardware and software. It is usually used to test and debug the hardware and software of a newly designed microprocessor-based system. The emulator has a multi-core cable which connects the PC of a development system with the newly designed hardware of the microprocessor system. A connector or plug at one end of the cable is plugged into the new hardware in the place of its microprocessor. The other end of the cable is connected to a parallel port of the PC or personal computer. Through this connection, the software of the emulator allows the designer to download the object code program into RAM in the system being tested and run it. Like a debugger, an emulator allows the system designer to load and run programs, examine and change the contents of registers, examine and change the contents of memory, location, and insert breakpoints in the program. The emulator also takes a snapshot of the contents of registers, activity on the address and data bus, and the state of the flags as each instruction executes. Also, the emulator stores this trace data. The user can have a printout of the trace data to see the result that the program produced on a step-by-step basis. Another powerful feature of an emulator is the ability to use either development system memory or the memory on the hardware under test for the program that is being debugged. This is the 9 summary of the use program development tools in emulator. The various steps in development of an assembly language program are given. 1. Define the program carefully. 2. Use an editor to create the source file for assembly language program. 3. Assemble the source file with the assembler. 4. If the assembler list file indicates error, then use the editor and correct the errors. 5. Cycle through the edit assemble loop until all errors indicated by the assembler are cleared. 6. Use the linker to link all object files of the program modules and library files into a single executable file. 7. If the linker indicates any error, then modify the source program, reassemble and relink it to correct the errors. 8. If the development program does not interact with an external hardware other than that directly connected to the system, then you can use the system debugger to run and debug your program. 9. The designer program is intended to work with external hardware, then use an emulator to run and debug the program. And in module 13, I choose activity number 5. Number 1, it can understand and execute the machine language program directly. That is machine language. Number 2 question. In this program, the instructions are written using binary codes which use only two symbols, 0 and 1. That is machine level program. Number 3, it is a software tool which, when run on a PC or personal computer, allows the user to type or enter and modify the assembly language program. That is editor or text editor. Number 4, in this program, the instructions are written using mnemonics. That is assembly level program. Number 5, in this programming, the instruction will be in the form of statement written using symbols, English word, and phrase. That is high-level program. That's all for module 13. Thank you and keep safe.